So in this question, we're given an FM signal and we're asked to find the maximum frequency deviation. So the frequency deviation, by definition, is the maximum deviation of the instantaneous frequency from the carrier frequency. And because that can be positive and negative, we take the absolute value of that. So that's what the question is looking for, the maximum frequency deviation. So that's your frequency deviation. Sometimes we just call it the frequency deviation without necessarily having to say maximum. So what do we need to find? We need two things. We need to find the instantaneous frequency and we need to find the carrier frequency. So the carrier frequency is right there. It's that value divided by 2 pi, but it's the instantaneous frequency that we need to find. So let's get this out of the way. Let's start by finding the instantaneous angle or phase. So that's just the bit between the brackets. It's the argument of the cosine. So it's 15 times 10 to the power 8 t plus 10 sine. The next thing we want is the instantaneous frequency. So that's just the derivative, the first derivative of the phase. So this is by definition. The instantaneous frequency is the derivative of the phase. So here we have constant multiplied by time, and here we have a sine. So if we take the derivative of the first, it's just the constant, the coefficient of t, and the derivative of a sine is a cosine, but we have to multiply obviously by the coefficient, so it's a chain rule, cosine 1550 t. And if we wanted to find the instantaneous frequency in hertz rather than radians per second, then we would take that and divide it by 2 pi. So it would be 15 times 10 to the power 8 over 2 pi plus 1550 over 2 pi cosine 1550 t. Now, what we want to find is the maximum difference between the instantaneous frequency and the carrier frequency. So given that that's the carrier frequency, it means that this is the difference term. That is that. And that will be maximum when the cosine is equal to 1. So the value for delta f is simply going to be 15500 divided by 2 pi. And I'm just putting that in the calculator, and that's 2467 hertz. So that's my maximum frequency deviation, or simply my frequency deviation, and that's the final answer.